In this video, we're going to have a look at the proof of Theorem 1. Now, just before we get started, seeing that this is our first proof, here's some important things to remember when doing a proof. It's much easier to remember if you break it up into chunks of, in general, what you're doing in each portion. Also remember that in a test or an exam, chances are the diagram's not going to be labeled in the same way. It might look a little bit different. So make sure you understand what those different chunks of your proof are. Don't just learn it off by heart in relation to the letters that are in this particular proof, because in a test or exam they're going to be different. Okay, so let's have a look what's in this first theorem. Now the first theorem says that the line joining the center of a circle to the midpoint, that's the middle, of a chord is perpendicular to the chord. So that means that if we have a line that's drawn from the center to the middle of a chord, then it hits that chord at a right angle. Okay, so the beginning of that theorem is what we're given. So if you have a look here, we're given this particular circle with center O, and we are told that AM is equal to MB. So the line goes from the center to the midpoint of chord AB. Therefore, what we need to prove, and you might not have seen this before, but RTP means required to prove, stands for required to prove. So that is what we are required to prove, that OM is perpendicular to AB. Right, so let's have a look at that proof. Often in proofs we need to construct something, and you'll see the construction's been done because this is in fact the memo. But you would need to construct the following radii. So you would need to construct, let me put them here in green. Construct radii OA, there's the one radius, and OB. Okay. First thing. Now what we're actually going to do is we are going to prove that triangle OAM and OBM are in fact congruent. So that's our next chunk after constructing, that OAM and OBM are congruent. And this is how we're going to do it. We know that OM is common, so we say OM equals OM because it's common. We know that OA is equal to OB. How do we know that? Because they are radii. And then we know that AM equals MB because that was given to us. We have enough information, in other words, 3 sides, to prove that those two triangles are congruent. Just don't forget your reason for congruency. That is side, side, side. So that chunk that we've just done is proving, so we need to prove triangles congruent. That's our chunk. Because it might be triangle PQR or XYZ, depending on how that triangle is labeled. Okay, let's look at the next portion. Obviously they're congruent, so what do we know about the two triangles now that they are congruent? Well, we know that M1 is equal to M2. Now see here, they're not actually labeled, so you are free to label them M1 and M2. Those are equal because of the triangles being congruent. But, hang on a second, we also know that M1 plus M2 add up to 180 degrees. So if you look at our two angles here, that one and that one, they add up to 180 degrees. So, therefore we know because they're equal and they add up to 180 degrees that they each must be 90 degrees. And voila, that's what we needed to prove. If M1 and M2 are each 90 degrees, then of course OM is perpendicular to OB. And that's the end of our proof.